Good afternoon, everybody. Hopefully, everybody's feeling refreshed after the post-lunch talks. So this talk is going to be about CI/CD for networks, whether it is a myth or reality. Right? So network engineers today are more commonly adopting automation practices, and as they start adopting automation tools and technologies, they're also being tasked with doing their work in a DevOpsy manner and to also adopt continuous integration and continuous deployment in delivery technologies and tools. So the objective of this talk is to lay some of those foundational baseline definitions with respect to network devices or network management, right? And we'll go through some of the challenges that we have observed as operators based on our history, and also we'll look and we'll talk about some practical tips and practical things that people can start adopting in order to bring in these tools into their environment. So my name is Ajay Chinampara, and I've been with Red Hat for about a year now, but previously I've been the operator of large enterprise networks for over about 20 years. And partner here is?
Yeah, Gerald Dykman, been with Red Hat for about 3 years, previously at Cisco. For me, I've sort of been voluntold to be here today, so I'm going to have a good time listening to this talk as well with everyone in this room. But just for my knowledge, who here is already automating in the network? Okay, and out of those hands, who is using Ansible to do so? Oh, yeah. All right, cool. All right, that's it. All right, I'll have fun viewing your talk.
Okay, great. All right, let's start with some basic definition of let's start with what is the idea of DevOps, right? So according to Wikipedia, the definition of DevOps is about a software methodology, right? So it's a software development methodology which stresses communication and collaboration and cooperation more than anything else, right? So the point here is that you cannot hire a DevOps engineer. It's a cultural thing, right? The stress is about communication and collaboration. So now let's take the definition and try and apply that in the context of how we manage our networks and how we automate our networks. In my opinion, based on this definition, two distinct personas emerge, right? One is that of a network programmer or a network application developer, and the other is that of a network operator, okay? So let's solidify that with an example, right? So let's say you're tasked to deploy an application in a data center, so that from a network perspective, the changes required for that might involve load balancer configuration, firewall configuration, routing changes, switching changes, right? A few different pieces of moving configuration. So imagine that configuration set as an application, and the person building that configuration to be the network programmer, right? And once deployed into the network, right, the person managing it, the person enhancing it becomes the operator, right? So these are not distinct people. The point here is that these are the two different personas with respect to the definition of DevOps that emerge, right? One is the developer and the operator. Okay, so let's establish a few more definitions within the context of network automation.
And just real quick before we move on, one of the reasons as to why I guess the industry calls it NetDevOps, sort of networks are the last frontier in the automation journey that's going on. And it's been difficult for network engineers to adopt automation because vendors don't necessarily make it easy to standardize across all the vendors out there. So, different tools have been introduced. Being from Red Hat, an example is Ansible to allow NetDevOps processes to take place. So, just wanted to mention that.
Okay. So from establishing the definition with respect to network automation, let's look at CI and CD as well, right? So first, let's look at continuous integration, right? By definition, a practitioner of continuous integration merges their changes continually into the main branch of a version control system, right? So let's unpack that a little bit and lay it a little bit plainer with respect to network automation. So two main tool sets emerge around that particular statement. One is the fact that there exists a version control system, right? And the second is that there exists a tooling or a build process that allows the developer to test their changes confidently, right? So while the version control piece is relatively easy to solve, the challenge, in my opinion, with respect to how network engineers are being tasked to adopt some of these tools and technologies, the challenge typically remains in that testing phase. And a lot about this talk is going to be centered around that. So moving forward, let's move on and complete the thought about continuous delivery and continuous deployment. Right? Continuous delivery is where, once you have enough confidence in your integration tests, you feel comfortable to send it to package it as a release, and now you're comfortable to push this release into your production. Right? You might subject it to further pipelines. You might want to deploy it into a staging environment. You might want it to be subject to certain approvals and other tests, right, before it gets deployed into production. Now, the distinction between continuous delivery and continuous deployment is simply the level of confidence that you have in your testing, right? So if you're confident in your testing that this can be deployed into production and it's not going to cause an outage, you can automate the full delivery process, right? Whereas with continuous delivery, you have a manual step where after all testing, just before you push to production, there is still some manual control point involved. All right, so
real quick, is there anyone actually doing continuous deployment with their networks today? Yeah, okay.
A couple of hands.
And this is what we see with a lot of our customers. We cover the public sector space, and all of our customers are working towards continuous delivery. And then it's a business decision or some manual intervention to actually push it into production, but we rarely see continuous deployment for networks.
So based on these definitions, let's do a walkthrough for a typical network change, right? So in this slide here, right, what I've tried to depict is, okay, you have the persona of the network developer who's built the configuration. Let's say that same example that I used, right? You want to deploy a web app into the data center, so that involves these different configurations. So they push these configurations into a version control repository. Now this version control repository has plugins or tools, or it can fire off a job that takes this infrastructure as code, potentially renders it as vendor specific configuration, and then ultimately push it into a testing environment. The reason I have question marks around the testing box before the configuration gets pushed into production is based on my experience, right? Based on, as an operator for large global data centers, one of the biggest challenges I've had with deploying changes is, what do I test? Okay, so based on my experience, I think this is the bare minimum set of things that you should test before you deploy any change into production, right? Before you deploy a change, you want to make sure that your changes are not going to break the existing application, right? You want to make sure that your changes are HA and performance, there's no performance degradation because of your change. You want to make sure that, finally you want to make sure that the change actually achieves what your goal is, right? These are the bare minimum things that you want to test before your change actually hits production. All right, so how do we test this, right? So testing, in my opinion, there are different places you can test this, right? So if your organization can afford it, right, to be able to have a staging environment that replicates your production environment would be fantastic, right? Because this is going to allow you to be able to test convergence. It's going to be able to test high availability. It's going to be able to test the same versions of the operating systems that are running in your production, right? But at the same time, other than the fact that it's going to be expensive to maintain a whole different environment that looks just like a production, the challenge is going to be, okay, now you've got to maintain another environment, right? So before you deploy a change, if there are different sections of your network, right, who gets to change what? Who gets to use this environment? How do you make sure that the configuration is always in sync with what's in production, right? So these are some of the challenges with taking this approach of a parallel production environment. Another option is testing with virtualized devices. Testing with virtualized devices sounds very, very attractive, right? And I think it's a great tool. But the key with virtualized devices is that we need to understand their limitations, right? So for instance, it's not always possible to get the exact version of the operating system that you're running on your production machines on a virtual machine, right? You might be able to do things like configuration linting to make sure that the syntax of the configuration that you're pushing to these virtualized devices are not going to break production, but you might not be able to simulate the exact changes. For instance, one of the challenges that I came across was if you had a particular module and port on a physical device where you wanted to effect a change, there's no real way on that particular virtualized machine's platform to exactly configure that. That port and module is not available, right? So then I have to build some sort of mapping to make sure that I understand that, in my test environment, this port and this module represents that port and that module in production, right? So these kind of things make it almost a non-starter, the amount of effort required, right? But virtualized devices are definitely critical to help enhance the way we do our testing.
And one thing I would say there is one of the main themes here is we're trying to cover types of testing you can do. It's just the nature of network operating systems today that make it difficult to be 100% sure once you deploy into production it's going to work that way. Another thing here is as you start to build out these pipelines and adopting these NetDevOps practices, you want to make your changes incremental, make it small. We're not doing massive changes anymore. We're doing constant small changes so that you can protect yourself from large failures. I'll shut up soon. So I always talk about the blast radius and why network automation can sometimes be scary is because a virtual machine goes down, some people are pissed off. A physical server goes down, you piss off more people, top of rack, even more. But if the network goes down, everybody's always pissed, right? So you want to protect yourself from those failures. So you want to build in good automation practices so that you can automate and follow these NetDevOps. All right, go ahead, I'll shut up.
Yep. So in summary, the virtual devices are great for management plane testing, right? So if you want to test out deployment of SNMP or checking how NTP configurations are going to work, those things might be good candidates for testing on virtualized devices. They're reasonably good for control plane, right? So if you want to test how the OSPF is going to converge or basic routing testing might be good. But when it comes to data plane, virtualized platforms have very, very limited feature sets. What about production devices itself, right? So some of us are fortunate to have a test environment to do tests, right? Many of us do our testing in production. At least that's how those were my options, right? Sometimes production is the only environment where you can actually make some of these changes, right? To a large extent, you might be able to simulate it and test it out in some lab devices, but when you actually make the change, it's a whole different set of variables you're dealing with, right? So the point of this slide is that if you're an experienced network engineer and if you have no other option and you have to test in production, just make sure that there is adequate communication, right? Make sure that those changes happen in very controlled environments and make sure that you have great backup plans, right? But in summary, if you have to test, if you're using production as a way to test your changes, please do not do that. All right. Okay, so those were the different options I think that we have today where we can do our testing, right? So what else can we do, right? We can still do smarter testing, right? I saw a number of hands go up when Gerald asked how many of you are automating your networks, right? So whatever tool you choose for automating your networks, right? Just make sure that there is a way for you to lint that particular tool. So the point here is make sure that when you choose your tool, make sure there is a way for you to validate your automation artifacts are good or not, right? So if you have a junior engineer that's making a change to your infrastructure, you want to make sure that simple things like linting the automation artifacts is possible, right? So this slide lists out a few tools, depending on whether you're using a Yang or YAML for data modeling, or Ansible or Python, or whatever other tools that you might use for your automation system. You have some means to actually lint your automation tool itself, right? So that's one thing you can do to enhance how you do your testing. Another thing you can do is to make sure that the configuration you're sending to the devices are good, right? So in this slide is an example of a tool called Ansible, where you can run your automation artifacts in what's known as a check mode, right? So the check mode gives you a visual clue as to what commands are actually being sent to the devices, right? So it still requires a manual, someone to look at the output and say that, okay, the commands that are being sent to the device are correct or not. But the point is that, it allows you to, it gives you confidence, right? It tells you, okay, what exact commands are going to be sent to the devices. Now, another way to lint configuration is to leverage virtual devices, right? So the virtual devices, so this is a great place for virtual devices, right? Send the configuration to a virtual device and allow it to fail if there is configuration mistakes if there are mistakes in the configuration that you're pushing to the device, right? So this slide shows an example of where an incorrect command is being caught because the virtual machine doesn't know what to do with that particular configuration item, okay? Smarter testing also involves being able to validate your policies, right? So you should be able to start writing tests, so independent of your machines, independent of your vendor platforms, right? So your automation should handle things like, so this one shows how we validate our SNMP policy, for instance. Right, so there are two policies listed here. The first policy is testing whether the SNMP RO string and SNMP RW string are the same, right? So ideally you want them to be different. The second policy checks the strength of the SNMP RO string, right? So these things are relatively easy to implement, right? These also function as way for you to validate new products that come into your environment, right? So you could take an existing policy and apply it to a new product and see whether the product is able to satisfy your existing policies, right? So if a particular vendor platform is unable to satisfy some of your products, that becomes a good selection criteria for you. So that's about testing, right? So these are some of the things that you can do to improve the testing in your environment. The other thing you can do, right, from a DevOps standpoint, remember from the definition of DevOps, the idea was that to improve cooperation, to improve collaboration between teams, right? So one thing you can do to address that is to address processes. So this again is from my personal experience of dealing with change control in enterprises, right? So I would submit a change. And while submitting the change, I'll realize that I couldn't select the right CI to affect the change. It would go through multiple discussions and peer reviews. And finally, I would appear before a change advisory board and explain to them why I would like to do my job. And then somebody would notice that I didn't choose the right drop down from the change control system, which is why the CI didn't show up in the first place. And so now they will reject my change control, and I'll have to wait for another 2 weeks, right? So that's definitely not DevOps, okay? So let's try to move away from there, right? So those are some of the things that we need to unlearn. So what we're proposing in this slide here is use GitCentric Operations as an alternative, right? So GitCentric Operations is probably a talk by itself, and it's a talk that I did at Ansible Fest last year, but the idea behind it is adopt something like Git flow or GitHub flow using branching strategies to potentially represent portions of your topology, right? The tools allow you to enable features like protected branches, right? So that you can still implement that audit trail. So the reason why the process existed in the previous slide is not because people like to inflict pain. It's probably because there are some audit requirements. There are some, you need some trail of conversations and approvals and things like that. My point is that by adopting more nimble tools and by adopting things that large open source projects use successfully by distributed people across the globe, we can make some process improvements in our environments as well. A critical component to all these is infrastructure as code, right? So we all love the vendor platforms that we work with most of the time, right? But being able to be independent of that vendor platform is critical for automation. The idea here is that you have a repository of specification, right? So whether you configure VLAN 100 as VLAN space 100 or set VLAN 100 should not be important, right? What's important is that VLAN 100 needs to exist in your environment. So that's the piece for you as your business, right? As an operator, that is what is important for you, that VLAN 100 exists. So that's a specification of your infrastructure. Store that as specification, store that as data structures. Then use any kind of rendering tool, right? So in this slide shows Ansible, but any rendering tool that's able to take this specification and convert it to whatever vendor specific configurations are required, right? That also gives you as an operator leverage over vendors, right? So your specification is not going to change, right? However, the implementation of the specification with respect to configuration, that becomes a variable, that becomes a negotiable thing.
So real quick, that's how, this is one of the harder, can you go back one slide?
Oh.
This is one of the harder things that I see when I work with customers is actually separating these two, right? If you're a traditional network engineer, IP address 192.168.1.1.255.255.255.0 is just how you think about a configuration. Right, what we're trying to do is whenever you configure anything, it's always going to be the same. The different parts are what we're abstracting out, putting it in a key value store, or that's what we call the specification here. So the engineering exercise becomes how you implement, right? You write that implementation of it, and you just feed it different data depending on which device you're working with. So that's sort of how you do this at scale.
Yep. And finally, one of the critical components of DevOps is communications, right? So there are tools, adopt the right tools to improve communications, right? So this slide shows you some example of what we have implemented in the past to encourage chat ops, right? So all the network engineers are in the same chat room. You have your tools like your version control system that can directly inform everybody if somebody made a change, if that change was tested, if the test was successful or failed, right? And after this talk, we'd be also happy to show you a demo of the screen cap here, which is pretty much a demo of a Slack command that enables your help desk people, right? Your help desk people can now potentially use these Slack tools or basically any of these communication tools to interact with the network, right? So this particular example will crawl through the network and find out whether a source to destination tuple is permitted in your routing infrastructure, right? Things like that makes communication a lot easier. Earlier I spoke about GitOps. Using Git as a way to communicate features, issues, even manage projects, right? Makes the communication open, makes the communication accessible, and it's no longer hidden away in emails. Using things like GitHub Actions allow you to trigger automated testing from your GitHub repository, right? So leveraging some of these ways to enhance communication becomes critical. Looking forward, right? So these are mostly opinions and observations of what's happening in the industry. My observation is that some vendors have embraced the success of Linux and have taken that approach for networks as well. One thing that's definitely sure is that all vendors are moving towards a distinct separation of control plane and data plane, right? Some of them have decided to go with a proprietary ecosystem where the software and the hardware are closely tied, whereas some have proprietary software and using white box environments, right? The point there is that if you remember one of the first testing slide that I had, right, to be able to test a replica of production, now that something like that becomes more feasible and a lot more cost feasible, I guess, if white boxes become the norm, right? It becomes a little bit easier to justify some of those costs. Finally, an interesting technology that's emerging is formal methods of testing, right? Formal methods of testing at a high level, it absorbs the configuration, and some of these tools also absorb the operational state of the network and together build a mathematical model of the network, right? So there's no emulation, there's no virtual machines here. It's a mathematical model of the network. And that is able to effectively test changes that are introduced into the network. Now, that is exciting, right? Because it makes the points of cost go away. It makes the points of version of operating systems, right? Those kind of concerns, it makes it go away. But some of the concerns it also raises are, these tools become yet another thing that network engineers need to worry about, right? And presently, based on my understanding, the learning curve for some of these tools are not, smooth or not. There is a significant learning curve. The other thing is how do these models keep up with vendor features and bugs, right? So if there are bugs in the hardware, do these formal methods, emulate those properly, right? If vendor introduces a new feature, how long is it going to take for these products to catch up? And finally, and I don't know if this is a valid concern, but I'm thinking as a network engineer, right? So as network engineers, typically we want an SLA for everything, right? So if you have a testing tool, and if you're going to use it with confidence to deploy into production, the automated deployment, and something goes wrong, right? Even though the tests pass, who becomes responsible, right? Those kind of questions are still out there, right?
So real quick, and you can leave it on this slide. So it all sort of becomes mixing all the testing strategies we talked about and using it sort of in parallel. So a model that I sort of recommend is to have that mathematical model to do the analysis and figure out what type of changes would occur if you deploy something, actually emulate that through virtualization and then do post-validation, right? So sort of bringing it all together, you can adopt CI/CD type practices. It's not true CI/CD, but that's sort of where the industry or where the customers that we work with are going towards.
Yeah. I was looking at the clock here and just making sure we have enough time for questions. But the key takeaways here is, right, as defined, continuous integration is not a reality in the network space today, right? However, the point is that the ideas of collaboration, the ideas of communication, right, between teams is still to be stressed, right? There still are tools that can be used, right? Even though virtual machines may not be satisfying every single key checkpoint that you need in order to test your environment, it gets you most of the way, right? So in conclusion, right, we are in an interesting phase with respect to network automation, right? The mathematical models, formal testing seems to be very, very promising, right? Vendors moving towards separation of control plane and data plane is also very, very promising, especially if the move becomes more and more towards white boxes. That's pretty much the talk. Thank you, guys. Any questions?
Dan Megorian, Hopkins APO. Excellent talk. A couple of observations. Let's see. First of all, on virtualized appliances, I think you were restrained even about your observations. We have been modeling, we've been testing various virtual appliances against their physical counterparts, and by and large, they have almost no relationship to them. So, they're somewhere in the same line of products, right? But they really don't look or act or config-wise. Now, they have their own set of utilities,
yes,
which is fine. But using a virtual to emulate your physical, that's no.
Yeah, I completely agree. And I think, now as a vendor, I can do a CI/CD demo for networks, completely. I can show the complete continuous deployment. But then I'm choosing my virtualized devices to show that simulation, right? So you'll see a lot of demos of CI/CD in networks. But in my opinion, the minute you try to bring those practices into production, it's going to fall flat. It becomes limited, right?
Right. So the second observation is when you were talking about vendor independence of stuff, and you didn't quite cover it, but a big part of that in my observation is that you have to constrain yourself to not use any of the vendor proprietary extensions. I think everybody knows that. But the problem is that means you have to suss out what they all are ahead of time and make across all your different appliances and restrain yourself so that you don't use them and don't take that piece of candy that's hanging right in front of your face.
Oh,
right?
Yeah, without question. I mean, but if there is a particular reason for using a particular feature, right, and at that point, that's a lock-in, right? At that point, you have decided that you need this feature for your business to be successful, and therefore, I'm going to make this choice.
I think sometimes people are not aware of what all of that.
Fair point.
Right.
Yeah.
Okay, the last point is this, that your last slide on modeling. Okay, operators, at least of my generation, tend to be operators, and modelers tend to be modelers. And APL is full of modelers, and they almost never touch the physical network or really know much about it, but they know their model really, really well. As an operator, I have time to go and learn all the nuances of those models. So I still think there's a big gap there, and I think you guys are sort of saying, yeah, we should weld those two together, but there's still a big gap.
There definitely is a gap, right? The reason I bring that up specifically is because, one is awareness, right? I'm not sure if everybody knows of the formal methods of testing is even possible, right? And the other is that, to me, that seems promising, right? In the hope that, this is hopefully going to be the way we can test, because virtualized images don't seem to be, a way to go forward. So I'm thinking what might be the alternatives, and mathematical models seem to be, a light at the end of the tunnel kind of a thing, right? I'm hoping that's going to be the one that solves our testing.
I agree with you, but they take too much mind share.
Agreed. Thank you. Yep.
Yikes. Rob Seastrom speaking on my own behalf. I am concerned that points 3 and 4 are much more permanent roadblocks than while the technology evolves caveat up there would seem to suggest. I have some experience in the deep distant past with emulating terminals, and that wasn't a moving field, right? That was VT100. It's this defined instruction set which corresponds to your mathematical model. Mm-hmm. And then you discover that actually you have to emulate all the bugs very well, and for the minor differential versions of the terminal which correspond to the slightly different compiles for different CPU-based control planes for different submodels of a switcher router or something. Yeah. The gentleman before me pointed out that the virtualized and the hardware often have nothing in common except for the name.
Right.
And likewise, I would love to have equipment that I was deploying in the field that mostly followed the mathematical model in the areas which I care about, which is tripping over the bugs.
Yep.
I have a pretty good handle on how Bellman Ford works, and I don't need a simulation to prove that to me.
Yep. Yeah.
But
No.
the tripping over the bugs is the thing that I'm really worried about for the continuous integration. That's what I hope for, and I don't see that that's.
Yeah, completely agree with you there. And I think, with that in mind, right, so I'm thinking the more prevalent white boxes and separation of control, the network operating system versus the data, whatever is running on the data plane and in the control plane, the more separation there is, and the more we have white boxes, hopefully testing can be a real.
Ivan's blog entry the other day said quite the opposite. Where have all the SDN controllers gone? So.
Okay.
And I think it's just until we get the next iteration of how network operating systems are built, we're going to be stuck with there is not going to be true CI/CD for the network realm. And that's sort of what we wanted to talk about today, because if you look at all this stuff out there, it's all about CI/CD for networks, continuous deployment. I mean, it's not the reality, so this is kind of what we wanted to bring to light today.
We can still be fully buzzword compliant. Reality and things. That's not a constraint. Thank you.
Thank you.
I think we're getting cut off. If you have a question, we can take it offline. Or.
Yeah, we're 10 over. We gotta be catching the holiday off. I'm sorry.
All right, no worries.
Thank you very much. Thank you very much.
Yes.